All right, hey there, ladies and gentlemen. Today we're going to look at domain and range yet again, except we're going to apply it to that's hard to say for me, real world situations. So here's a graphic that I want you guys to kind of jot down to have as an example. When we talk about the parabolas and all the different parts, I'm going to start up at the top where we have the vertex. This is the maximum height. So how high does the object, or what is the maximum height of that item? And usually the y value tends to be time. You know, how long does it take it to get there? So either way, you know, usually time is y in this case when we're talking about a parabola. The y-intercept, this is where x is 0. And this is usually going to be where the item starts. And then the zeros are other stopping points, I guess I should say. So this would be where y is 0, so you would have an x value, and where y would be 0. Oops. So that kind of puts in perspective what the different parts of this graph mean. So here are some examples of some real world parabolas. A rainbow, a bridge, definitely is an example. Some more bridges. You can see that U shape there. A roller coaster. A water fountain of some sort. Fireworks. A basketball is a big example of a parabola. Kicking a football. Angry Birds, and if any of you played that. Oops. Oh, that's pretty. All right, just some fun facts and interesting things to see. Whoa, still going there. All right, to that. So this is an example that you might see. It says when an object is thrown up or down or dropped, they give you an equation. I'm going to tell you now, you're not going to have this memorized. They will tell you, but what you have to pay attention to is what the variables represent. So for example, the h is height, t is time, s is the initial height, and so on and so forth. So there's an example here. It says you kick a football into the air with an initial velocity of 15 feet per second. Assume that the football is on the ground when kicked. So you would have an initial height of 0 because that's on the ground. They tell you the initial velocity is 15. And from there, you would answer questions. You would substitute these values where they belong. So you would have h equals negative 16 t squared plus 15 t plus 0. So you don't really even need that plus 0. From there, you can graph this parabola and be able to answer some questions like what is the maximum height and all of that referring to. So here's an example. It says a ball is shot out of a cannon into the air with an upward velocity of 40 feet per second. The equation that gives the height is here, and t is time. So first thing, as I was mentioning before, is that we need to designate that h is the height and t is the time. So what I also want to point out is time is x, h is y, so to speak. So we're going to find the maximum height. attained by the ball. So what we want to find is the output value. So what we need to do here is, so essentially the vertex is the x and y value, right, of those maximums. So x is the time, so that'll take how long will it take to get there, and then y will be the actual maximum height. So let's start by finding our axis of symmetry, which would be negative b over 2a. So this would be a negative 40 over 2 times negative 16. So we would have negative 40 over negative 32. So 40 over 32 is actually 1.25. Oops, it should be a 5. So 1.25 is the x, which means 1.25 seconds. So it takes 1.25 seconds to reach that maximum height. Now let's see what that maximum height is by substituting 1.25 for x, or for t, I guess I should say. So we would have h of t, or h of 1.25, equals negative 16 times 1.25 squared plus 40 times 1 point, totally, writing over what I have here, some plus 1.5. So as I solve this using Desmos, negative 16 times 1.25 squared plus 40 times 1.25 and then plus 1.5. So it looks like 26.5 would be what we're looking at. And it looks like it doesn't give us, oh, feet. So our vertex is 1.25, 26.5. So 1.25 seconds to reach a height of 26.5 feet. All right, here's another one. A ball is thrown in the air. The path of the ball is represented by this equation. I'm not going to worry about graphing. If you want to graph on your own, you're welcome to do that. So what I'm going to do is talk about the maximum height of the ball. So in order to find the maximum height, h being the height, t being time, I'm going to take that equation, h equals negative t squared plus 8t, and I'm actually going to find my axis of symmetry. So that'll be the amount of time it takes. So negative b over 2a, so negative 8 over 2 times negative 1, so negative 8 over negative 2 would be 4. So it's going to take 4 seconds to reach this maximum height. So now I'm going to substitute a 4 for t. So we would have h equals negative 4 squared plus 8t. So, oh, not t, sorry, 8 times 4. Okay, so 4 squared is 16, so it'd be negative 16 plus 64. Which is 48, and in this case, I'm assuming feet, doesn't give us units. So it takes 4 seconds to travel 48 feet.